Hey guys, Mrs. Dan's here. So I had told you that we're going to take some notes starting on page 25. Um, Page 23 is really where the lesson starts, but you'll do that tomorrow in class as you're due now. And 24 just has some additional notes. I just really want to get you started with what this next lesson's all about. Again, the more practice you do, the better off we're going to be. So I want to get you practicing now. So at the top of the page of page 25, I just want to go over a couple of things that you should already know, and I want you to write this down with me. If I were to ask you what 7 times 0 is, I'm sure you'd all tell me 0, right? Anything times 0 is 0. So if I asked you what 0 times -3 is, you're going to tell me 0. Okay, this is called the zero property. Sometimes we call it the zero product rule, right, where any number times 0 gives you 0. So if I were to do it in reverse and say 6 times what equals 0, of course you would tell me, oh, this is a 0. Because anytime we multiply two numbers together, and one of the factors is 0, it means that the product will be 0. Okay, only one of these factors has to be 0 in order for the product to be 0. So if two things are being multiplied and I get 0 as an answer, maybe this first factor is 0 or the second factor is 0. One of the two factors is 0. So if we go and look at number 1, what we see right there is two things being multiplied, two factors. So we have a k plus 1 being multiplied by a k minus 5. When I multiply these two factors, my answer is 0. So using that zero product rule, what we did up here, we know either the first factor is 0 or the second factor is 0. Either this k plus 1 is 0 or this k minus 5 is 0. And this is how we write it. We take the factor and set it equal to 0, and we take the other factor and set it equal to 0. Well, if k minus 1 is 0, what's k? Oh, k would be -1 in this case, because -1 plus 1 is 0. On the other side, if k minus 5 equals 0, what's k? Oh, k would be a 5, because 5 minus 5 is 0. So there's two different answers that k could be. K might be a -1, or k might be a 5. We can write it in set notation. We could say k is -1 or k is 5. And this is what we're doing today, or tomorrow actually. So if we take a look at number 3, we can see that there's two factors being multiplied together and their product is 0. So what does that mean? It means this first parenthesis, the 4k plus 5 equals 0, or this k plus 1 equals 0. Now I was able to do number 1's solving for k in my head. If k plus 1 was 0, I was easily able to figure out that k had to be a -1. Maybe down here you want to do a little bit of algebraic work. Maybe you want to subtract 5 from both sides and get 4k equals -5, and then divide both sides by 4. And you can see that k equals -5/4. You're allowed to leave your answer as -5/4, which is the same thing, of course, as -1 1/4 or -1.25, but I don't see anything wrong with improper fractions. On the right side here, where k plus 1 equals 0, you might just know that k equals -1. Again, if you want to show some algebraic work, you just subtract 1 from both sides, and that's why k is -1. So k is -5/4, or k is -1. If I wrote it in set notation, this is what I would write. There's a set of answers. There are two possible answers for k. And now, if we were to do number 5, you can see that number 5 is not set up like number 1 or 3. With 1 or 3, I had two factors being multiplied together to get me a 0. But now I look at 5, and I don't see two things being multiplied. That equals a 0. So I have to get it in the right form. I have to get this in standard form. When this is in standard form, I also get it set equal to 0. So the way we do that is using some algebraic work. I see a -5 on the right side of the equal sign. I want that to be a 0. So I'm going to add 5. Whatever you do to one side of the equation, you have to do to the other side. So now over here, I have a 0. On the left side, by combining like terms, I get an x squared minus 11x, and these combine to be plus 24. Now I have a trinomial. We know that trinomials can be factored into the product of two binomials. So I do want to try and get this to look like number 1 or number 3, where I have two factors being multiplied to equal 0. Okay, so let's get number 5 to look like that. If I make my two sets of parentheses, I keep my equal 0 on the right side. The x squared, I know can be an x times an x, but this 24, I'll write out to the side. Maybe it's a 1 times 24, maybe it's a 2 times 12, maybe it's a 3 times 8, maybe it's a 4 times 6. Remember, you get to do trial and error and figure out the factors so that when I do my outers and my inners, I'll get the -11x that I want. If I want to add together to get a -11x, I actually know that all of these factors must be negative. A negative times a negative would give me the positive, but when I add the negative and the negative, it stays negative. So which factors do you think would work? I'm hoping you're seeing ahead and recognize the -3 and the -8 should work. When I check my outers, I get -8x, and when I check my inners, a -3x, and -8 minus 3x is -11. So now this is set up as the product of two factors equaling 0, which means that maybe, I'm just going to change my color, maybe the x minus 3 equals 0, or x minus 8 equals 0. Now I ran out of room, so I'll come over here. If x minus 3 equals 0, or if x minus 8 equals 0, then add 3 to both sides, x is a 3. Add 8 to both sides, x is an 8. These are the two possible answers for x. I can write it in set notation if I want, but that's actually not necessary. So you can see that for this lesson, we have to be able to factor. Okay, we're going to get it into standard form. It'll be set equal to 0, and then we will factor. Write down these steps right here. Write it in standard form, set equal to 0, and then factor it. So let's take a look at number 9. And this is going to be the last problem we do. So let's get it set equal to 0 by combining these like terms. I'm getting it in standard form. So this is an equation in standard form. I notice, I won't forget lesson 1, I notice is a GCF. Don't forget your lesson 1. The GCF happens to be 6. And now I'm left with n squared minus 3n minus 4 equals 0. This is a trinomial that can be written as the product of two binomials. So n squared will break apart to n times n. Things that multiply to be a negative 4 would be like a negative 1 and a 4, or a positive 1 and a negative 4, or a negative 2 and a 2. I need my outers and my inners to equal negative 3n. Any clue about which factors would work? Again, hopefully you're starting to see ahead like I can, and I notice that these factors would work. Plus 1 and minus 4. If I check my outers, I get a negative 4n. When I check my inners, a positive 1n, and those do combine to be a negative 3n. So now this is where I'm going to use my product rule, the 0 product rule. So there's actually 3 factors here. 6 is being multiplied by the n plus 1, which is being multiplied by the n minus 4. So out of these 3 factors, something must be a 0, because if their product turns out to be 0, one of those 3 factors is 0. Is 6 equal to 0? Obviously not. So I don't have to worry about anything with that 6. Maybe the n plus 1 equals 0, or maybe the n minus 4 equals 0. If I subtract 1 from both sides, I get n equals negative 1. If I add 4 to both sides, I get that n equals 4. So there are 2 possible answers for n. It could be a negative 1, or it could be a 4. And that's what we're in for tomorrow. So I was hoping 10 minutes. It says 11:47. Have a good night. See you tomorrow.